All right, so section 9.2, we'll spend a couple days in. It's called special right triangles. So there's two different kinds. We'll do one today and one tomorrow, but it basically provides a shortcut so that you don't have to do the Pythagorean theorem. Maybe sometimes it might be easier, but so 45, 45, 90 triangle. So really, if you just see a right angle and one of them that's 45, you have a 45, 45, 90 triangle. So what it ends up happening is that, and we haven't talked a lot about this, but because both of these are 45 degrees, like the length of the side across from an angle, there's a relationship. It ends up being, because they're both the same, that those sides are going to both be the same. It's an isosceles triangle. There's base triangle like theorem that we talked about forever ago, but those sides will be the same on a 45, 45, 90 triangle. And so the way that, like, the book does like this, where it says, okay, x, and then x times the square root of 2. Like, that's the relationship. The way that I learned it when I was in school, we did this thing called a 1, 1 square root of 2. And the 1, 1 was like the x, like, sides. So really what this is saying is, like, if you're going from this side to the hypotenuse, you're going to do times the square root of 2. So if I had, 45, and this was 4, and I wanted to, solve for, let me make those a little bit neater. Let's just do A and B. Very quickly, A equals 4, and B equals 4 square root of 2. Done. Okay, so it's just the B side, or the hypotenuse, whatever letter is there. It's just whatever that side is, square root of 2. Okay. A is 6, B is 6 square root of 2. Again, if it's 45. I know that triangle's a little bit more sloppy, but okay, so it's just times the square root of 2, or just stick that number in front of the square root of 2. Oh, it's a half square root of 2. It doesn't matter what it is. Okay, it won't be negative because it can't have negative length. All right, so times, it's the side times square root of 2. And we said, well, it's times the square root of 2 from the side to the hypotenuse. Is like these, where it's just 4 or 6 or whatever, and the other one is the same, and then the hypotenuse is 6 square root of 2 or 4 square root of 2, whatever it is. So that's the easy version of the problem. So then we have a middle version of the problem. So let's say, well, this isn't that much harder, but let's say this was 10 square root of 2, and it wanted us to figure out A and B. Well, it's just this number that's in the front. Okay, so A equals 10. B equals 10. Okay, so simple, hopefully, we see like that relationship. Okay, so then what if this was 8? So just like on this, well, if you're going the other direction, you're going to divide by square root of 2. And this is where the problem becomes, like, this is the hard version of the problem. Okay, so you would really do like 8 divided by square root of 2 like that. And so the difficulty becomes we're not allowed to have a square root in like the denominator, or we're not allowed to divide by a number that's a square root, unless it's like square root of 4, which is 2, or square root of 9, which is 3. Okay, so what we have to do is what's called rationalize the denominator. And so just match the denominator and multiply. So on the top, just 8 square root of 2. On the bottom, because they're both underneath the square root, I can multiply them together. Well, but square root of 4 is 2. And then these two numbers, I want to look, can I reduce? Not the number under the square root, because this is out of this, like this is just a 2. You can divide square roots, you can multiply square roots, you can't do like one that's a square root and one that's not. Okay, this is all stuff that hopefully is coming back from algebra, but 8 divided by 2 is 4 square root of 2. Okay. All right, let's look at another one. So the ones that are maybe, I don't know, sometimes people say they're easier, sometimes they're harder. Just depends on your individual preference, I suppose. What if it was a 9? Okay, well, I do 9 divided by square root of 2. It doesn't matter which one of the two sides are the same. Okay, and then I do the same thing. Well, I can't have a denominator. And so it looks identical to the problem above, just instead of an 8, it's a 9. And this one, 9 over 2, can't simplify it. So we're done. Okay, so the special triangles, like to use Pythagorean theorem to figure out the lengths of the sides, you need 2 of the sides, and then you can do a squared, b squared, c squared, and you plug it into the right one and solve it. Special right triangles, if it's a 45, 45, 90, you just need one side, and you can figure out the other 2. The a and the b part match, so that's easy. Or the x and the y, or whatever, the 2 sides that make the 90-degree angle work. Or are the same, excuse me. And then the hypotenuse is, again, times the square root of 2. If you're going the opposite direction, then you divide square root of 2. Okay, so there's really only, well, I suppose I could do this. Then we could have one like this top part. Okay, where you know the hypotenuse, but you have the square root of 2, and then it's just the number that's in front. Or you could have the hypotenuse as a whole number, definitely the hard ones. Divide by square root of 2. So use these 2 as examples. There's not anything different that really can happen, except the 8 is now a 12, or whatever, just the number's different, or the 9 is the 3. That's the only thing that can change. Okay, I was going to say there's really only like 3 different kinds of problems, but I forgot about one. So if I said that this one was 5 square root of 2, and I want to figure out that side. Okay, well, we said from here to here, we're going to multiply by square root of 2. So 5 square root of 2 times the square root of 2. I'm allowed to multiply those square root of 2's together because they're both under the square root. And the square root of 4 is 2, so the length is 10 for A. Excuse me. Okay, so I guess technically there's 4 different kinds of problems. The first one, and then same thing with this one. You could have 5 square root of 2, or 12 square root of 2, or 19 square root of 2, or, it's going to be the same way. Okay, so that's a worksheet because the problems in the book, there's just a few of them, and they're kind of like weird sometimes. So knock out the worksheet, and then just memorize that 1 square root of 2 thing, and special right triangles will be your friend. All right, have a good day, and we'll see you tomorrow.